All right, so now we're going to get into another component of the AC system. We're going to move up here to the evaporator. We're working our way through this system. I have an evaporator right here out of a vehicle. I don't recall what it's out of, but they're all real similar to this. This is, if you've ever had a heater core out of a vehicle, it looks a lot like a heater core within the vehicle. In fact, they're both housed in the same unit behind the dash, the HVAC case itself. So this evaporator is removed because of a leakage problem. But let's talk about what it's supposed to do. Okay, so we've got two lines here, an inlet and an outlet on here, and I can, for the most part, identify those lines by looking at diameter. Now this is out of a different system that we haven't gotten to yet, a thermal expansion valve system. This is out of but I'm going to use it as an example for our cycling clutch orifice tube here. So if we enter this evaporator through one of these lines, which would be this line right here coming off the orifice tube, which is referred to as a low pressure liquid line there. So we got low pressure liquid coming into the evaporator itself. Now this system here is another form, just like the condenser, where we have multiple paths to pass through. It's harder to see on this, but it is made up of the same design, meaning that if we come in to this tube right here, it's not going to fill up all the way down and transfer over to the other side and then exit out. So there are parallel paths here, and not only that, you can see the divide right here of two separate tanks. Okay? So meaning if we come in right here on this side, well, we're going to stop right there on that, and we're going to pass to the other side here. Okay? And we're going to drop down to the bottom, and we're going to come back, and then we're going to come over to the other side over here, and then go through, and then when we come up to this section here, then we come on over and we can exit out of the pipe right here. So once again, we have what's called a series parallel evaporator system here. So if we run that across multiple times, we can get the maximum heat absorption that we're looking for. So unlike the condenser, the responsibility of the evaporator is to absorb heat. Okay? As we send this refrigerant into the evaporator, it is a low pressure liquid, meaning we need that liquid to evaporate, and evaporation takes place when we heat something up. So in this case, we're going to heat up the refrigerant by using a fan to blow either recirculated air inside the cab, or we're going to draw fresh air outside. Either way, we're going to take that air, we're going to push it through here and pass through. So the ambient air itself will make contact with all of the fins that are on here that have transferred that cooler temperature to the fins, and we're going to take a warmer air and run it across it. That warmer air going across this, that heat will be absorbed into the refrigerant and carried out, and the cooler air that we blew across it comes out the other side, and that will be coming out the vent, the floor, or the defrost, or a combination thereof. Okay? So our goal is to take that refrigerant, absorb the heat that we're passing through it, and send it out and let it continue on its path. In that case, it'll leave and get to the accumulator. Okay?